We're going to learn water chemistry today. I'm going to give you a lot of pointers that you don't always find by reading, stuff that I picked up over 34 years of experience. If you can ever get a chance to read the book that comes with this test kit, I've gotten more out of this book than hours and hours of water chemistry classes. They have a way of explaining to you in a more simple terms how to do what to do. And then in the back of the book are charts that will make your life a whole lot easier, that you'll be able to determine what needs to go in this pool at what times and be confident on what you're doing. Now the first thing when you start to take your sample of water is always make sure that you clean your vial. You never know who went before you and what they did. You always rinse that out, and I just use the water that I'm testing to do that with. And that way you know you're always going to get true readings. We're going to start out here by testing the chlorine and the pH. The pH is the acidity of the water. Both of these are very important and should be maintained at all times. The back of your test kit gives you these instructions, but I'm going to tell you as we go. We're going to start off with DPD reagent number 1, and we're going to do 5 drops of 1, and then we're going to do 5 drops of number 2. Now on the bigger side, this is for the pH, we're going to do 5 drops of number 4. Now take your caps and put them over top, that way you're not contaminating anything, and just give it a shake. If you hold it up to like a white background, you'll get your truer colors and it's easier to read. So if I test this right now, there's no chlorine at all in this water at all, and the pH is a little bit low. Not too bad, about maybe a 7.2 to 7.4. Now we take that same sample and we use base demand. If we were too high, we would use number 5, which is acid demand. How much pH minus does this pool actually need? This again makes it all simple and easy, so you're putting in the right amounts when you're supposed to. But since we're low, we know we need to add some base, so we're going to count our drops, one drop by drop, until we get orange a perfect 7.6. So 1 drop, 2 drops. There's our perfect 7.6. So we know that we need 2 drops to bring that up to the proper balance. Now before we get too far, we're going to go ahead and check for the next thing, which is total alkalinity.
It's really all the same equipment.
Now instead of filling it to the 40 milliliter line, we're filling it to the 25 milliliter line. We're going to start off with number 7. This is a chlorine neutralizer. If there's not any chlorine really in the water, you only need 2 drops. If you have a high chlorine or bromine reading though, you want to use more than 2 drops, and this does not tell you that in the test kit. Again, I don't even bother counting the drops. I'll just give it a good squirt. It's just a chlorine neutralizer. You're getting rid of the chlorine and the bromine to get a truer test. Number 2, we're going to do 5 drops of number 8.
Bill, can I help you? Anybody?
Now this is where you need to get your swirling technique down. You want to swirl that water without it going all over the place, and that takes practice. As you see now, we're green. I would warn you when we're doing bromine that if you do this and that comes up red before we ever put in number 9, you have no alkalinity to the pool whatsoever. That would be a bad thing. That would be very acidic. Now we're going to count these drops, drop by drop, until this turns red. Okay, 9 drops equals 90 parts per million. Not too bad because we want to keep it right in that area, really somewhere between 100 and 120. So not too bad, but we want to raise that up just a little bit. Now this is where it gets confusing. We have a low pH and we have a little bit low alkalinity. You always adjust your alkalinity first, before your pH. And this is where it takes some getting used to of experience. But if we raise that alkalinity up to where it's supposed to be, we're going to end up with a perfect pH in this instance. Now in the back of the book, there's charts. And let me tell you, these charts are dead on right. They're not wrong. If you know the gallons that's in that pool, you can't get it wrong. Now, we were assuming so far that this pool had about 35,000 gallons of water.
117,000.
117,000. All right, if we want to be 100 to 120 and we're 90, obviously we want to raise this up about 20 to 30 parts per million. You come to the chart, to raise alkalinity using sodium bicarbonate. Okay, if we come down here and we say 30 parts per million, and we go up here to 100,000 gallons, that's 42 pounds. I read that right on my chart. Now, if we just did 100, we got 17,000 more gallons to go. My next chart has a 10,000 gallon, which is another 4.20 pounds. Then there's a 5,000 gallon at 2.10 pounds. And then we got to double the 1,000 gallon, so 6.72 ounces, almost 7 ounces. So we'll do another 13 ounces, okay? So all in all, this pool needs 48.43 pounds of sodium bicarbonate, not sodium carbonate. And again, this is where I think they were getting it wrong, and things would be so much better and stay more stable doing it the proper way. Okay. Now we're going on to test for calcium hardness. Everybody thinks this isn't important. When you're dealing with a gunite or a concrete pool, this is super, super important. If you don't keep the calcium hardness up in a concrete and gunite pool, it'll actually erode away at that finish and ruin the finish of the pool. So this is where a lot of times you go swimming and you'll get sharp pieces that you walk on. You know, I've even seen people come out of them with bloody feet. So very, very, very important. Starting off with reagent number 10, we need 10 drops. Now we're going to put in reagent number 11, 5 drops. Now I split this up, and this is again from experience. The test kit doesn't tell you that. If you'll split these up and do what I just did, then your chemicals mix much better for testing the calcium hardness. Now I want to go back to number 10, and we're going to do 10 more drops. Again, you won't ever read anything that'll teach you that. Now we got a nice blue color, and we're going to watch for the color change. It almost changes to almost a yellow, but the different things can give a little bit different chemical reactions, but we're counting our drops drop by drop until that changes. Okay, I used 100 drops of reagent number 12, and it still didn't change, which means that we're very, very hard water. And either somebody put too much calcium chloride in, or I would have a good guess that this is well water. Okay? You want to be 300 or more. And the guys that do the gunite, they really want more like 350. But trust me, if you do 300 or better, you won't have any damage happening to the pool. Well, this doesn't need anything. What I would be concerned about with this is it's so hard. If we had to like do any lowering of the alkalinity, that would be a problem. But to raise it, you know, and other things to raise pH, put chlorine in, that doesn't affect anything. So at this point, I would leave this calcium hardness exactly where it's at and not even be concerned about it. But it can change. So it's very important to do that test, at least do that test once or twice a week. Your other tests should definitely be done 3 times a day, every day, day after day. To raise the alkalinity, because that's low, which will take care of the pH at the same exact time, we need 48.43 pounds of sodium bicarbonate. Not soda ash, not sodium carbonate.
Okay. This soda ash, does that go the wrong direction?
That raises.
That raises.
Alkalinity plus sodium bicarbonate raises the pH and the alkalinity. Soda ash, sodium carbonate, mainly only raises the pH. It doesn't raise the alkalinity as much. That your money is better spent doing the sodium bicarbonate. Now if the alkalinity was right, but the pH was low, then you want soda ash, sodium carbonate. That's where it gets confusing.